The session will be start shortly. So good evening everyone. Myself Jishnu Radhakrishnan from Pantech e-learning. On behalf of Pantech e-learning and IETE, I welcome all participants for Day 7 project. So today's project title is nothing but forced money identification using neural network. So here we will be working with a simple neural network regarding with convolution neural network layer by using the Keras pre-processing function as well as OpenCV in Python. We will be able to detect whether the money is able to be identified or not, and we will be seeing what is that particular existing method they have been used. So what are the previous literature studies we have been done for this. If they need block diagram. So I hope everyone is audible. Once again, I welcome you all. Pantech has been originated in the year of 2004. We have expertised in such domains like deep learning, Internet of Things, embedded system, VLSI, FPGA, and robotics. And we are conducting this particular program in collaboration with IETE Mumbai. The Institution of Electronics and Telecommunication Engineering in India's leading recognized professional society devoted to the advancement of science and technology of electronics and telecommunication, which has been founded in the year of 1953. So they are providing the wonderful laboratory experiences as well as all the technical terms regarding towards the electronics as well as communication departments. So they provide a vast area of technology in multiple domains, especially in electronics and communication. So today's title is regarding towards the forged money identification using neural network. So the forged money is nothing but in order whether it is a forgery type of money. Like we used to say that many fake notes are available nowadays, and whether it is a fake note or it is a real note. So we will be training some sort of data regarding towards it. So from that particular data, we will be creating into a basic model, and then whenever we just run it in the live performance with the help of our camera, whichever is available in our system, and running the neural network, therefore we will be able to get that particular data, whether it is a kind of original or a duplicate kind of note. And if it is original note, therefore it will be completely what to say, detecting whether what kind of note it is, else it won't be detecting that exact one. So whenever we go for this kind of particular implementation, so we must go step by step what was the previous thing and why this objective has been taken. So therefore whenever we go for this kind of objective oriented functions, definitely you may be thinking what is the main activity of this particular device. So definitely nowadays you can see that there are many kinds of money counting machines, and within that particular machine, whenever we place that particular money based on the thickness of each and every money that has been applied, so with the help of that thickness it will be able to sort it out, and if there is any mismatch over there, it will be stopping it. So similar to that particular system, here it has been developed with the help of the neural network, as well as this can also be said as currency deduction using an artificial intelligence. So in that particular model only we are working, and this model is completely the real-time model. So whenever we work regarding towards this forgery money, so we have to train the data set according to it, and we have a already pre-trained model which has been previously trained for the currency deduction. So that particular model is being trained with the help of the Keras and TensorFlow. So here also we are going to test the particular model with the help of Keras, TensorFlow and OpenCV, where TensorFlow will be working at the backend function. So now let us start. So today we will be seeing regarding towards this project as the following, like objective, existing system, literature survey, proposed system, block diagram, module explanation, algorithm, and project demo. So first let us analyze the IEEE paper. So here I have the existing method paper over there. So here within this particular paper, it is written as Indian currency deduction using image recognition. So based on this particular recognition, and they have also done it as an MATLAB. So MATLAB, I hope everyone knows that it is a kind of software which is used for various domains as a simulation software. Because whatever the things we develop in the MATLAB, it is very easy to implement, and at the same time we will be able to perform multiple tasks. So rather than saying MATLAB is a software, it can also be said as an operating system for the engineering domains. So including aerodynamics or electronics, electrical, and embedded, VLSI, everything can be simulated over there. So by using the MATLAB only, they have simulated, especially for Indian currency deduction. They have used here as image recognition technique. So here we are applying both image recognition as well as neural network. Okay. So therefore now let us see what is that particular abstract is able to explain over there. So whenever we see that particular abstract, therefore the paper currency counterfeiting, they have mentioned it as a most biggest problem. Yeah, definitely whenever we go for this shops or whenever you go for the bank, yeah, the main problem is whether without knowing by ourselves or without our knowledge itself, we will be getting some sort of fake notes. So that particular fake notes, and it is completely against our Indian country. So to detect that particular things only, we have designed this particular system. So based on that particular Indian currency only, they have focused. Here whatever I am going to show also the Indian currency only. So they have done the particular study and they have implemented in the mat files, which is known as the MATLAB image processing toolbox. Then what are the functions they have implemented over there? Those can be said as the LBP is significant process. So this LBP method they have applied. So for just a moment. Okay, so we were at LBP. So based on that low binary pattern, they will able to recognize the pattern as well as the texture of the particular image, whatever they provide as input. And by using this principal component analysis, they will be able to train the particular data. They will be able to measure what kind of percentage that particular error or any changes are being compared over there. So they will also use this Euclidean distance algorithm in order to maintain or that compare the data set as well as the test image. So based on the data set, if any distances or if any pattern gets changed over there, therefore definitely we will be able to come or we'll be able to just notify what kind of problem it has occurred over there. So what are the key points they have been allocated over there? Therefore, image recognition using MATLAB, old Indian currency, they have used LBP known as local binary pattern. Then Euclidean distance to compare the dataset as well as test image. Principal component analysis to analyze the entire percentage of the test as well as trained image. So here in this methodology they have provided us clearly. So based on that particular pre-processing, they have applied to the RGB, converted to the grayscale, then they applied the PCA algorithm to analyze the principal component. Then from that particular PCA oriented, they have transferred towards the LBP known as local binary pattern. From after that, recognizing the pattern, measuring the distance using Euclidean formula or algorithm. So based on that particular algorithm only, they will be able to match whether it is fake or original note. So here you can see how it is able to process each and every section over there. But here it is completely improvised with the neural network. Just it is able to detect whether it is a that particular standard note or not. Okay, now what is the objective of this particular project? So the main objective is nothing but to detect the different Indian currencies using the neural network. So among that particular pattern or any color change, that also can be easily based on the particular patterns and designs that has been trained previously, and this particular by calling that Keras TensorFlow, that kind of backend, and using OpenCV as the front end function, we will be able to recognize what kind of each and every product is provided as test data. So what is that particular existing system? Now we have seen in our base paper that has been detailed over here. So here we will be using that particular image acquisition purpose by using that browsing data over there. So within that particular acquisited data, it is pre-processed. Pre-processing is nothing but converting from one form to another form, mostly the color image into the grayscale, because from grayscale only they will be able to get a binary section, because our system, not only our system, all that particular electronic components which is running in the form of computers, they will be able to read binary data only in the form of zeros and ones. So if we just convert the threshold or binary from directly to RGB, therefore the exact value which is to be read by the system is not available. So that's why only whenever we go for the pre-processing, first we will be the first step is nothing but converting from color to grayscale. So now let us go regarding towards the literature survey. So according to the literature survey, so the first thing is nothing but a recognition of fake currency note using convolutional neural networks. So they were applying the same machine learning as well as the CNN. Within that, they are having the problem of counterfeit. So then think, but the counterfeit problem is nothing but the detection. Okay, so whenever we just come under the particular detection over there, it is not able to recognize, or they were not able to just compensate the system oriented functions, while compared to the this particular project what we are going to do now. Then automatic recognition of fake Indian currency note. So this is also they are using the image processing technique, but instead of the machine learning or deep learning, they have used a edge detection function. So with the help of this particular edge detection function only, they were able to allocate whether it is a currency note or not. Then Ethiopian banknote recognition and fake detection using support vector machine. So here they have implemented the image processing and at the same time the machine learning. So they were using that particular algorithm known as support vector machine, and whenever they have implemented this particular function over here, it was not accurate while compared to the simulated one in real time, because in simulation they were able to get a good kind of accuracy, but in real time they were not. So now what is the proposed system regarding towards our function? So within this proposed system, we are applying the discrete wavelet transform, and from that particular discrete wavelength, we are also calling this kurtosis as well as the recognition oriented there. And here we are mainly using the neural network in the form of convolution layer. So that particular consistent convolution layer, whichever we call with the help of the Keras pre-processing technique, which has been already trained towards that particular model. So therefore, from that particular comparison only, we will be able to get this as an test or matching towards the database. So whenever we work regarding towards this kind of functions, definitely we have to go on each and every steps over there. So here wavelet transform as well as the kurtosis value and all regarding towards the efficient matrix value only, according to the each and every image which we show directly towards the system. So here whatever the system I am just going to implement, it is in our own system only, which is known as a normal computer of Windows laptop. So within that we have installed all the required packages regarding Keras, TensorFlow, everything. So from that only it is able to get this kind of function, and this pre-processing whatever I am saying, discrete wavelet transform or kurtosis, skewness function, everything is automatically taken place in the function known as Keras pre-processing technique. So we have a file known as Keras, which is a part of TensorFlow only. So within that Keras, there is a function known as pre-processing, which automatically pre-process the data once we call that particular function. And within that pre-processing, we have a detailed section like conversion and binary separation, like kurtosis, skewness. Then we can go with filter application. So everything is defaultly applied over there. So this kind of techniques we have applied over here in order to reduce the stress that is available over the code. So now let us go to the block diagram. So here in the block diagram, we have a set of functions like input currency node, pre-processing, PTP pattern extraction, GLCM features, and NN classification. And from the database, we have trained templates, pattern recognition, NN training. Okay, and finally, we will be able to identify whether the currency is there or not. So whenever we just provide input towards that currency, we will be just compiling towards directly the function of pre-processing technique. So whenever we go for that particular pre-processing technique, generally we have to just apply the grayscale or whatever the filters we require, and the pattern extraction, it completely goes regarding towards the functions, analyze regarding towards in which pattern each and every images is taken as input, and in which pattern we will be able to compare with the database. So the same thing only, the pattern extraction as well as pattern recognition. So the both will be applied in the same format only. That's why only we can see it in the input as well as the database. So generally whenever we just see regarding towards the project, this can be splitted into two different types. One is the input section and another one is the database section. So here you might be thinking that input has another 3 blocks, and whereas this particular database will be having only 2 blocks. But whatever it is provided at the upper state, the same functions only it is being carried out even in database. So that's why only we have just given it as feature extraction, because GLCM comes under the particular feature extraction technique, and PTP is known as the normal kind of pattern extraction which is available in OpenCV or any other image processing technique. So from that particular pattern extraction only we will be able to compare it. Okay, so once the database gets trained, before that the feature extraction and the pattern recognition will be done. Then after that the training will be done in the particular convolution layer, and that particular trained model, here we will be able to see it as the tuned currency model. So this is .model file. So within this only we have trained all that particular function, and this is currency mobile net, which contains the original data set of the currency over there. So these two will be pre-trained model. So within that particular pre-trained model only we will be using that neural network function. So within that particular neural network function, it is created in the name of convolution layer with a low resolution 2D layers over there. Difference between PTP as well as GLCM. So definitely whenever we go for this PTP as well as GLCM, PTP is completely used to recognize a pattern. Okay, so the pattern in the sense in what way that particular data is provided, and what are the structures available in that particular data. So that are all known as the pattern. Then this GLCM is known as the gray level co-occurrence matrix. Since we have pre-processed our image into the grayscale, so from that it will be able to analyze the data with the help of the GLCM feature extraction. So the image whichever is present only in gray, we will be able to obtain the matrix data with the help of the GLCM feature extraction. It can also be said as only the gray image detection can be done over there. because normally the gray images, it is very difficult to get the data, since it contains all the colors applied in a same way. So to separate only that particular required data whichever we need, or to make some changes while compared to other. For example, uh, we can go with the face recognition. So this face recognition, in the sense, my face is in some kind of shape, and my friend's face will be in another shape. So therefore, whenever we apply GLCM over there, it will be able to uh, extract that particular feature between the two faces. Okay, but whereas the pattern is nothing but the structure that has been designed previously. So in this way only we will be able to compare this. So that is only we are providing the pattern extraction as well as GLCM feature extraction. The screen was not clarity, in the sense, are you not able to see any data or anything? If it is obtaining in the form of pixels, please check your network connection with that YouTube clarity. And here we are streaming in 720 pixels. Okay, so therefore whenever we go for this particular feature extraction or this kind of application, therefore it will be then sent to the NN training, which is known as the database. Like there will be more amount of data sets, maybe for 100 rupee note itself there will be around of 50 to 100 pictures, or there will be 200 pictures over there. So like that, for each and every rupee notes will be there. Then from that we will be extracting each and every features and pattern. Then it will be sent to the neural network training, and after that neural network training only we are going to obtain it as a model. So the model whatever we see over here, these two models are obtained after the neural network training only. Now we are calling this particular model into our system. So here you can see, you can call this particular model or the previous model, whichever you see. This also can be called over there. Two models can be used. So by comparing that particular model data only, we are going for the NN classification. So once we get into that demo section, we will be seeing that entire function. Now let us go the detailed block diagram explanation in the form of modules. So here we will be seeing regarding towards the pre-processing, feature extraction, neural network, and currency classification. The pre-processing is nothing but the stages which and all it is processed. The feature extraction is completely regarding towards the GLCM. So then the neural network regarding towards the convolution neural network, and currency classification, in the sense what and all the currency it will be able to classify. So the pre-processing, it mainly works with many kind of deep learning libraries, especially in Keras or TensorFlow. Even OpenCV2 pre-processing is also available with the help of CV2 functions. That can be set as each and every elaborated function over there. We have to apply like cv2.imshow or cv2 dot convert from bgr to gray. So like that kind of each and every command should be provided in line by line. But whereas if we go for that Keras kind of pre-processing, that particular deep learning library, it will be taking automatically whether it is data, text, or any sequence. So here we have provided it. Like from Keras pre-processing, we are importing with the image, where the Keras applications, we are calling the sections as pre-processing input. So from that particular model only, here we are providing the input section, which is able to predict the data set or that input image. Okay, so in this way only we are applying the pre-processing section in our project. So that's when it has been set as the Keras deep learning library. Generally, the Keras mostly works with the deep learning tools only. Along with Keras, the TensorFlow also will be coming, which plays in a backend role. So once we start to run this particular program, we will be able to see what kind of model it is. So in this pre-processing, we will be just converting the image size or that particular image clarity, or we can say that here I am meaning the size of the image as the weightage or that particular storage of the image, because a heavy kind of stored image, it is very difficult to read by the system. So therefore that particular conversion of grayscale or that reducing that particular size like from 10 kb to 4 kb, in that particular reductions and all done in the form of pre-processing only, and hence the pre-processing is nothing but converting the normal image to the multiple variants according to the system. So here itself you can see, first it is a color image, then it is converted to the grayscale, and then the image has been scintilized. So now itself you might have got idea, while converting from color to grayscale itself, some amount of kb has been lost, and from that grayscale, whenever we are converting with filters or we are compressing that particular image, therefore once more that particular size gets reduced over there, and now this particular size is fit to our processor, which is able to read the data. Then this particular feature extraction is nothing but it is completely works only with the help of grayscale or binary image. So whenever we go for the grayscale over there, we have to apply the GLCM. So the basic appliance whenever we go for neural network, the GLCM is must, because the gray level co-occurrence. So what is the level of the target image in a grayscale? That particular occurred data will be monitored in a matrix format. So here itself we can see, so within that particular grayscale itself, it is able to extract which one is red, which one is green, and which one is blue. So for that particular kind of implementations only we are using this GLCM over there. So here from starting we can go, the image is converted into the two different forms. So this color image is sent to the grayscale, and from that the binarization, then that binarization is applied with the help of mask, like separating the object as well as its background. Now the color image as well as the mask image gets combined over there, and therefore we will be able to measure it in two different ways, either in color or in grayscale. So based on that particular wavelength, by applying the GLCM known as gray level co-occurrence matrix, by applying that particular data towards this optimal wavelength system, we will be able to separate what is the level of red present in that particular image, then green present in particular image, and B which is present in the particular image. So each and every data can be easily separated from the grayscale. So normally whenever they are using this basic image processing technique, it is also possible to work only with grayscale itself without applying any kind of neural network, because the GLCM has that much amount of option which will be able to provide some kind of accuracy. But with the help of GLCM, it is not possible to work in the form of artificial intelligence. So that is the main reason they are just applying this GLCM and a neural network in order to create a high level as well as instant processing over there. So if you have any doubt till here, you can just post it in the chat box. Yeah, the 720 pixel is too high. According to your viewing possibilities, you can change in your YouTube options. So why we are just implementing in high clarity? Because there are many losses. Even the 720 pixels itself, there are occurred with many losses. That is the reason. If you guys have any doubt till this feature extraction, therefore we will be working it. Here, Keras library is used for pre-processing section only, especially in test input image, because already the trained data set has been obtained in the form of model, which can be worked with the help of multiple Keras functions and DNN, known as deep neural network. So among that particular deep neural networks only, we will be able to access the algorithms like CNN, RCNN, BPNN, and Google Linux, PyTorch. So in the series and all will be coming under the DNN, and among that CNN is being applied over there. So guys, if you like this particular kind of tutorial classes, you can just like and share. You can also put your comments over here, and also you can share this particular video towards your friends so that they will get any initiative idea regarding towards this projects. Because your support is more important to us. Yeah, coding will be explained during the demo session. The masking and optimization. So definitely whenever we go for that masking, it comes under the layer. Okay. So the binarization in the sense converting a grayscale image into the zeros and ones. So here, according to us, that particular product or whatever it is able to detect over there, the black part is detected as 1. Sorry, the black part is detected as 0, where the white part is detected as the 1. Okay, so in between there is no such kind of variation like 0 0.5, 0 0.9 like that and all, not there, only 0 and 1. So with the help of that particular masking area, it is able to detect some object is present over there. Okay, and with the particular based on the object, before this particular process, like you have seen before that binarization, you have one more process just converting to the grayscale. So from that particular grayscale only the pattern is able to recognize from that. So from that particular pattern recognition only we will be able to apply the mask. So by applying the mask we will be able to get some layer over there that this is a structure. For example, if I am showing any of the rectangular box or any other kind of devices like any cube. Okay, so within that cube, if I show it towards a system, and if it is able to convert into the binary, therefore it will be seen as an entire cube over there. So it will be able to recognize that particular progress. So once we start to work with this edge detection in Canny and Sobel kind of applications, you will come to know how that masking layer is being applied over there. Then optimization. So this particular optimization is nothing but after that masking we will be just combining the both the color image as well as the masked image over there in order to fetch out each and every region through the grayscale itself. So for that we have to optimize the masked image with some color input over there, whereas the system won't be able to display what and all the colors are present over there, whereas we will be able to extract the different planes of colors which is present in that gray image or optimized image. Okay, so now let us go regarding towards the neural network. So whenever you work regarding towards the neural network function, neural network, it is a vast area while compared to the image processing techniques and all. So here we are combining both technologies like deep learning as well as the image processing. This particular different kinds of functions is different domains. Like deep learning is completely comes under the depth analysis of each and every program. So like for example, if we are just going with some sort of application, uh, for example, can we go about E equal to mc square? That is one of the famous formula in our physics. And we also have some derivations and some constant values for it whenever we are deriving it. So if a person is applying only that particular E equal to mc square, that will be a normal kind of learning only. Then whenever we want to know each and every part of that particular E equal to mc square, in the sense, it can be said as the deep learning. So then we go for that particular kind of deep learning technique. We need multiple layers over here. So what kind of layers, in the sense, we can go with, for example, whenever you are storing some sort of data into your phone, definitely it will be having different folders over there. So here consider each and every data as each and every folder. Like for music one folder, for photo one folder, video one folder. So this particular each and every layers only we will be able to compare it. And this entire section will be shown as the storage. So the same thing only we are also going over here. Like with the different layers, we are providing some input data, and each and every data is scattered to the different layer. And finally all the data will be merged into the same section, and from that same section we will be able to recognize whether this object is being matched with the dataset or not. How to implement the neural network by using TensorFlow. So within that particular TensorFlow, we can directly create a set of networks in 2D or 3D. First, we have to select whether it should be 2D or 3D. So by selecting, most of them will be applying for 2D images only. So from that particular 2D, we have to read that particular image, and from that image which has been read by a variable, that should be splitted into multiple layers. So that layers we have to decide that particular size. So once we start regarding towards that algorithm, I will just explain that formulas and that architecture over there. Therefore you will be able to know how to train the neural network over there. And after that particular neural network functions, we will be straightly going in order to classify whether the object is being detected or not. So here it is particularly using with multiple frames or single frame itself. So that particular single frame itself, it will be able to compare the trained dataset and test dataset. Therefore it will be able to classify that object, and here our object is completely our money. So now we are going to see regarding towards the convolution neural network. So Mr. Vishal Sarkar sir, here that particular formula is nothing but you have to apply this into that common formula. So regarding towards this common formula, it is number of images into image width, image height and image depth, and number of images into feature map width, feature map height and feature map channels. So this formula is applied for convolution neural network. So if you are choosing any other algorithm to work with TensorFlow, that particular formula you have to choose it over there. It depends upon the particular depth analysis and the formula basis only. Based on that formula only, we will be able to train the neural network. So here for this particular implementation, I have said in starting itself that we are using convolution neural network, and this convolution neural network, it consistent with multiple layers, and within this particular layers itself, here it can be simplified into a convolution 1 layer with kernel padding, max pooling, convolution layer 2, then max pooling, then fully connected layer and fully connected layer of 4. So totally we will be considering only 3 layers. The final layer is considered only for the output. Okay, so the 3 layers, whatever we use it plays a major role over there. Like the input will be in the size of 28 into 28 with depth of 1. So normally since we are using that 2D images, definitely the depth is considered as 1 only. If you are using only 3D images, the depth will be increased. So now we are sending that particular input towards the first layer. The first layer size is 24 cross 24 into n1 channel. So according to that number of channels or the whatever we are creating in that single layer, therefore that particular data will be uploaded over there. Okay, so that's why only the 28 into 28 has been reduced the size into 24 into 24. Then from there we will be taking into the reduction of 2 cross 2 max pooling. This is also set as a 2D function only. So from that it is converted over there into the convolution layer 2 level, which is known as 12 cross 12 into n1. Then once again towards the max pooling, which is 8 cross 8. So here you can see on the multiples of that particular decrement. So first it was 28 cross 28, then 24, then 12, then 8, and finally it reaches towards the 4. So within this particular 4 or the final convolution layer, we will be having many number of channels, and each and every channels will be having small data of the trained data set. So that particular small data is activated with the help of ReLU activation. So by using this particular ReLU activation, we will be able to connect the neural network in a particular order. So here that neural network, whatever it is mentioning, the object only. So that object will be connected in the same layer in which we have given it as input, but there will be some changes whenever we look over there. Like input will be in little bit clarity, or which is able to observed by us, but in fully connected sections we won't be able to see as much clarity, but the system is able to understand according to the pattern or whatever that structure is present over there. And finally, with the number of errors, we will be able to receive the output. So by calculating this dropout only, we will be able to measure the accuracy in our system. Okay, so this calculation, or to reduce the particular dropout only, we will be using this epoch value. So many of them might have noticed EPOCH. So with the help of that epoch, most of them will be applying it for 10 iteration, 15 iteration, 20 iteration. But whenever we are applying it in our system, just make it 10 and below, or make it as a standard value of 10 iterations. Because if we increase more than 10, it definitely takes the time in order to hours and hours. So hours and hours means it goes beyond over there, like 4 hours, 5 hours, 6 hours, like that. Many time it may take regarding for the convolution or any kinds of neural network training. Definitely it takes more than that, because our system processing is designed only to that particular function only. And if you are trying to run more amount of data within our system itself, definitely there will be a kind of speed damage, or the processor heating issues. There are many chances to occur this kind of problems. So definitely, if you are interested to work in deep learning and all, try to get a good environment with a graphics section. So now let us get into the project demo. So here I have that particular Anaconda navigator and ADAS lane vehicle. So I am opening that particular terminal. So within this terminal, I have to access the data set. I mean, the path of the data, not data set. I have accessed it. Now before going to it, let us go a short through in our coding. So here we are using to read the images in multiple functions like CV2, NumPy, Pillow, Keras model, Keras application, matplotlib, Keras pre-processing, Keras models once again, and play sound to play the audio. But there is some audio problem in my system, so therefore there will be some lag over there. So kindly apologize for that. So these are that main practical functions which we are going to use in our today's project. So first we are defining the prediction model. So the model we have been already created over there. So that particular model we will be calling into the main function, and before that we will have to follow some what to say, some kind of steps over there, how the prediction should be done. So the prediction, the image will be taken as input, and from that it will be converted into the array. Then the dimensions will be expanded with the help of NumPy. Then we will be providing the pre-processing section which is available from the Keras, and finally we will be able to predict the model. So now this will be the function of the prediction. Now we are getting into the main function. So first here we are using our models known as currency mobile net original dataset. Then it will be, once the model gets loaded over here, it will be printing it as model loaded. Then cv2.video capture, it is being used to access our webcam. So to provide it as an initial counting, we have provided this data over here. So initially all that nodes whatever we have trained, it will be in zeros only. Then if that particular frame reading is less than a approximate value, it will start to read that particular data through the camera. So then image from array, so what we have done here over that particular array, it will be called over here, and that array will be called as the RGB area. Then that particular area will be resized into 244 into 244. So normally the resizing value will be in 128, 128, because that is that particular neural network or depth sizes provided for the deep learning section. Then here we will be applying our prediction method from the predict model. So to calculate how much amount of area it is able to cover. Then from that we will be calling our array section. So from that array section, the calculation will be done in form of maximum probability. So the maximum probability count, when it is reaches near to 1, therefore it will be able to display what kind of data it has been provided over there. So here I am providing some labels for each and every data like background 50, 500, 100, 10, 20 and 200. So these are the labels, and these labels will be compared with the results. So based on that particular count, first if it is 50, it will be displaying 50. Then if it is 500, it will be displaying it as 500. If it is 100, it will be displaying it as 100. Then 10s, 20s, 200s and background section. So everything will be read in the form of color scale only, which is known as cv2.cvt color. So here, in order to paste that particular data within that screen itself, I am using the font option, which is known as cv2.puttext. So whatever it is able to recognize over there, we will be able to see on screen itself. Now we are appending the list of each and every data, whatever we have trained over there. So based on that maximum count only, we will be able to, not maximum count, maximum probability. So based on that maximum probability only, we will be able to get that particular data. So for that, the count we have been provided over here, and the first index will be called with the help of max position. So here initially, if there is no data over there, it defaultly goes for no currency. but here it will be displaying it as a background function over there. So once it gets directed over this particular position, therefore it displays as 50, and the sound also will be played over here. Then similarly for 500, 100, 10 and 20. Okay, and finally the CV2 dot video capture release. So now I'm going to run that particular code. So it takes some time over there. So due to that system processor, there will be some fluctuations. Therefore, our model has been loaded. Generally, when we start to work in this deep learning, definitely the system got to the slow method. Now it is detecting only the background, and finally it has been started to detect it as 50. So there is an audio lag over here. I have changed over here towards 20. Oh, it is upside down. Yeah, therefore it is able to recognize it as 20. So in this way only it will be detecting the multiple notes. 50. So I have said now that there will be some audio lagging, that is due to this particular processing speed only, and I'm extremely please apologize as for this particular issue. So if you have any doubt regarding towards this, you can just put it in the chat box. So if you want to get regarding any function of this particular project, you can just approach our project inquiry link, which is provided in the description box. We also provide projects for final year research projects and mini projects. We also provide trainings in internships, certified training, STTP, workshops, and FTP. We also provide products for lab kits, hobby kits, and IoT modules. So if you have any doubts regarding towards this particular project, you can just put it in the chat box. And we will also be providing the quiz link. So participate in the quiz and get the attractive rewards of specialized certificate provided from IETE. Thanks to all in order to participate in this particular project webinar. So if you want to reach us directly, you can reach us in these places at Chennai, Coimbatore, Trichy, Vijayawada and Hyderabad. We have also provided our contact number as well as our contact address. Everyone can reach over here. So okay guys, thank you to all participants. Please attend the quiz and get excitement rewards. So thank you all. We'll meet you next time with a wonderful project. Till then, bye to all.